pictures up on the board right now. One is the logo of the Houston Astros, like baseball, right? Major League Baseball. And another is a picture of a train. The numbers below the Astros logo, 8-2, is their record in the last 10 games. 8-2. They're the best team in baseball over the last 10 games. I'm not an Astros fan, but I appreciate the fact that they're doing really, really well. 8 wins, 2 losses in the last 10 games. My question for you is, what do they have in common? What do the Houston Astros have in common with this train that's barreling down the tracks? You can give me a one-word answer for this, or you can give me a several-word answer for this. Depends on how you want to phrase it. Anyone? Yeah, Mason? Yeah, they both have momentum, right? A baseball team or a hockey team or a football team that's got a bunch of wins in a row has momentum, right? A train also has momentum. But what is it about the baseball team and about the train, for that matter, that is the reason why we say they have momentum? Like give me a multi-word answer now that explains what we mean when we say they have momentum. Yeah. What did you say? It's hard to stop them, right? Yeah, they're moving forward, and it's hard to stop them at least. Not can't be stopped, but hard to stop. We're going to loosely define momentum. This isn't the real definition, but it's going to be a way that helps us to understand what we mean by momentum. We're going to loosely define it as how hard it is to stop something. The Astros are hard to stop right now, right? When you're on a roll as a sports team, it's hard to stop that team. Basketball team, hockey team, baseball team, whatever. A train is also hard to stop, but for a completely different reason. This one is more psychology, right? This one is more of a psychological momentum. A sports team is on a roll, like they're confident. And a team comes up against them, they're not so confident. You feel like, oh man, I can't beat these guys. But it's only psychological. This is more of a physical momentum. And this is what we're going to talk about in Physics 30 is physical momentum, right? Real momentum. How hard it is to stop something. But physical momentum, how hard it is to stop something physically, is due to 2 factors. What are they? What do you think those 2 factors are? What's one of the things that makes something physically, not psychologically like the Astros, right, but physically hard to stop? What's one? Yes, mass. The heavier something is, the harder it is to stop. What do they say? A train takes like a kilometer or something to stop when it's at full speed. A ship, like a fully loaded tanker, takes like several kilometers to stop. Why? Even if they're not moving very fast, they got a lot of momentum. They have a lot of momentum because they have a lot of mass. Mass is one thing. It makes it hard to stop. What's the other? Yep. Velocity, yeah. Somebody this morning said speed. Close. It's actually velocity. The mass and the velocity. That's why the real definition for momentum, the technical definition, the real definition, not the everyday understanding definition that I just gave you, but the real definition is the product of an object's mass and velocity. I give you both of these definitions. This is the one that I like the best, to be honest, but this is the one that if you ever get asked on a test, that's the one you want to give me. Now, I'll be honest with you, something like that's not asked all that often, but if it is, you give me the real definition, the product of an object's mass and velocity. Mass is a vector scalar. You guys remember the difference? Yeah, scalar doesn't have direction, vector does have direction, right? Mass is a, velocity is a vector, right? So what's momentum going to be? Vector, yeah. When you multiply a vector by a scalar, you get a vector. Momentum is a vector because velocity is a vector. Now, there's another term that you learned in Physics 20 that reminds me an awful lot of momentum. Does anybody know which one I'm thinking of? Yeah? Inertia. Yeah, good. Inertia. It's not the same thing, but man, is it close. Does anybody remember the definition for inertia? There's a couple different ones, like a couple different wordings of it, but More or less? Yeah. Yeah. Tendency of an object to keep doing what it's doing. In other words, the tendency of an object to resist a change in motion. A tendency of an object, you could say the tendency of an object to resist stopping. Doesn't that sound an awful lot like momentum? But it's bigger than that, right? It resists stopping, but it also resists slowing down. But it also, if it has inertia, resists speeding up. And it also, if it's got inertia and is not moving, it also resists starting. It's a more general term. It resists any change in motion, not just stopping, like momentum. What do you think inertia depends on? If it resists any change in motion. Has more inertia because it has more mass. Yeah, it only depends upon mass. Unlike momentum, that depends upon mass and velocity. I got two pictures of a train right now. One's in a station and one's moving on the track. Pretend they're the same train, okay? The one that's at rest in the station, does it have inertia? Yeah, it does, because it has mass. Yeah. What about the train, the same train, we'll say, that's moving on the track? Does it have inertia? But wait, the train that was at rest had inertia. The train that's moving can still have inertia? Yes. Why? Because it has mass. If it has mass, it has inertia, right? What about the first train again? Does it have momentum? How come? Because it doesn't have velocity, right? It has mass, but no velocity. What about the second train that's moving down the track? Does it have momentum? Wait a second, it can't have momentum, it has inertia. Can it have both? Sure it can. You can have just inertia if it's at rest and has mass. You can have both, inertia and momentum. Can you have just momentum? Is that possible? Yeah? No? No, it's not. It's not possible because to have momentum, you need mass and velocity. To have inertia, you need just mass. So if you have momentum, you already got the mass that you would need for inertia. Does that make sense? Okay. This is your data sheet, your equation sheet. If you look in the bottom left-hand corner of your data sheet, you're going to see this tiny little equation, probably the shortest equation on that data sheet. P is equal to m times v. I've circled it there. I'll make it bigger here, though, on this page. P, the symbol P, lowercase p, stands for momentum. I don't know why it's a P, but it is. By the way, it's not a capital P. A capital P would be what? Yeah, it could be pressure. It could also be power that we learned about in Physics 20, right? But lowercase p is momentum. Notice it has that little half arrow over top of it as well, which tells us it's a vector. M stands for mass, yeah. V stands for, oh, by the way, what would the units for mass be? Kilograms. Watch that, right? How many people take chemistry right now? None of you? Oh, one of you? Watch out, because in chemistry you use what for mass? Grams, right? So if you're going back and forth between physics and chemistry, you know the difference, right? But sometimes it's easy to just, you're not thinking and you just use grams by mistake, right? So just watch it. You've got to use kilograms here. V stands for velocity. And the units for velocity are, probably the most common conversion is kilometers per hour to meters per second. Let's say we've got 90 kilometers per hour. I want to convert that to meters per second. Anybody from my Physics 20 class know how to do that? Yeah? How do you do it? How do you do it? What do you do? What did I teach you last year how to convert that? Yeah? Right, right. What you've got to do is say 90 times 1,000 is 90,000 meters. Oops, one too many zeros. 90,000 meters. And then we divide by, well, there's 3,600 seconds in 1 hour, right? That gives us 25 meters per second. Make sense? The reason that I asked for my class is because I know the other class learned a shortcut. What's the shortcut? Divide by 3.6. Emmerich's now saying, like, what? That's all you got to do? Divide by 3.6? Why did he make us do this? Well, just because I wanted you to know how to do this, right? But in the end, there is a shortcut, and if you divide by 3.6, you'll get it every time. You got to be careful, though, right? Because sometimes we have this little brain freeze and we forget and multiply it by 3.6, right? But the way that you did it, you're not going to get it wrong, right? You're going to get it right every time. Divide by 3.6 works. Hey, what do you think the units for momentum are? Units for momentum. Remember, energy, we multiply 1/2 times mass, kilograms, times v squared, meters squared per second squared. Kilograms times meters squared per second squared. We just kind of shorten that and make it a joule. We don't really have a short form of the units for momentum. Momentum is just mass times velocity. It's just kilograms times meters per second. Man, it would be nice to have a short form, but on the other hand, it's like, you don't even have to remember this one. You just look at the equation and it kind of tells you what the units are, right? We got one example for you today. Example number 1, this is on the sheet that I handed out to you at the beginning of class. It says 145-gram baseball. It's traveling west with a velocity of 90 kilometers per hour. What's the momentum of that baseball? Now I'm going to pick up a red pen here. I haven't used the red pen yet today. Red pen for me is when I want to draw attention to something. I don't use the red pen for just writing on the board. I use it to draw attention to stuff. What do you think in this question I might want to draw attention to? What do you think, if I'm not careful, I might make a mistake on? Grams. Yeah, grams, not kilograms. Right. Now, you got to convert that to kilograms. How do you do that? How do you convert grams to kilograms? Yep, Mason? Yeah, it's divided by 1,000. We're going to say the mass here is 0.145 kilograms. Now, if you forget whether it's multiply or divide, that's okay. You know what you should do? Guess. And then check your guess. It's okay to guess, as long as you check your guess. Like, let's say that oh man, is it multiply or divide by 1,000? I'm going to go with multiply by 1,000. So let's multiply 145 by 1,000. I get 145,000. Does that seem reasonable? When I check my guess, it seems completely unreasonable. So therefore, I must have guessed wrong. That's okay. That's okay that I guessed wrong, as long as I checked it to know that I guessed wrong. It is divide by 1,000. Okay, when I do that, 0.145 seems reasonable, right? Anything else? Anything else I should red circle here? Or highlight, or however it is that you want to draw attention to it? Yeah? Yeah, definitely kilometers per hour. We got to convert that to meters per second. The velocity is, Emmerich, do you remember the shortcut? Don't you remember the shortcut? Yeah, divide by 3.6. When we do that, we end up getting 25.0 meters per second. Anything else? There is one more thing that I would draw attention to. In the end, like, what I want you to draw attention to is what would lead you to a silly mistake. But one thing that I would do. Yeah. Yeah, it's west, right? It's what momentum's a vector. We need the direction. This is west. Like, how often are we going to forget that west thing if we don't draw attention to that? So I'm actually going to put a little negative in front of the 25. Rather than write the word west through the problem, I'm going to make it negative for west. And then we'll just assume positive is east, negative is west. All right, I'm looking for momentum here. Looking for P. And we know, listen, the only equation that we've learned this year is P is equal to m times v, so I'm going to write that down. Mass is 0.145 kilograms, and my velocity is negative 25.0 meters per second. We multiply those together, we get 3.625, or negative 3.625 kilograms meters per second. How many digits should we have this rounded to? What is it? Yeah. Yeah, if you look back at your data, 145, 90.0, all 3 digits. So here's what I like to do. Underline 1, 2, 3, and then I'm going to put a little arrow on my 4th. The arrow one is the one that I look at to see if it's 5 or above. No others. I don't care if it's 3.6259439.8. Doesn't matter. All I care about right now is that 4th digit. It's a 5. So what do I do with the 2? I make it a 3. I round it up, right? If it's 5 or more, I round it up. If it's 4 or less, I round it down. Negative 3.63 kilograms meters per second. Final answer? Yep. There is another way that I could express that. Anybody want to tell me what it is? I could say what, David?
3.63 kilograms meters per second west.
Right, I could say 3.63, positive 3.63 west. Is it okay to say negative 3.63 west? No, because that would be east. So pick one or the other. This is the way that I prefer myself when I'm doing problems, but it's no more right than saying positive 3.63 west. I just personally like it better. Here's what I'd like you to do now. And you got probably enough time to finish this up in class. Worksheet number 1, which you can download these worksheets on Google Classroom, or you can go home tonight and print them off. They're also, as of right now, up on the board. Worksheet number 1, questions 1 to 4. Watch out for the little things, right? Units, directions, whatever. Draw attention to things that you think might lead you to a silly mistake. Okay, these are relatively straightforward questions if you pay attention to those little things. All right, let's get to work.